Hello, my name is Anton Kleshchev. I'm a professional software architect with 15 years of software development experience. Today we're going to be talking about the way to account for risks in estimates for software development projects. Before we start, please like and subscribe to not miss any future videos. We have a lot of stuff about software development planning getting ready to be released to this channel very soon. So stay tuned. Okay, let's get into it. Usually, when we think about an estimate, we think about a single number. For example, 100 man days or 100 story points. However, what does this number represent? Is it a positive outcome or negative outcome? Is this estimate rough or precise? Can we adjust this estimate based on the risk factor? All these questions are great and legitimate because, first of all, we must say that the estimate is a probability measurement and doesn't belong to the subset of exact numbers. A method for accounting for uncertainty in estimates is the use of a range of values instead of a single point estimate. Instead of determining the project cost as one specific number, a range of possible values can be identified covering planned estimate while considering uncertainty. This allows for the possibility of changes during the project and prepares for them in advance. The range can be schematically represented as a cone of uncertainty, a concept that visualizes the levels of uncertainty in the process of developing a software project. As the project progresses, the understanding of requirements and conditions remains vague and unclear. At the very beginning, the cone is wide, indicating a high level of uncertainty. At this stage, many factors can affect the final outcome. Implementation possibilities, technological limitations, changes in client requirements, all this creates a significant noise around the project. Over time, as requirements are refined and tasks clarified, the cone begins to narrow. Initial uncertainty is replaced by clearer expectations and a better understanding of the final product. As the project approaches completion, the level of uncertainty becomes minimal, and teams can confidently estimate costs and timelines. Let's review an example. Suppose we have a project with just a single line as a requirement. Let's say implement a payment gateway solution. In the beginning, the vast number of the requirements are not clear. For example, what this gateway will be used for, which payment methods it will support, what interfaces are the most important for the end user. We can identify the stage as initial project concept. Statistically, according to the cone of uncertainty, an estimate for the stage will have a range of outcomes anywhere from 0.25x to 4.0x. In practice, this means that if the project is given an estimate of 100 days, based on historical data or just pure expert judgment, the possible outcomes can be anywhere from 25 days, being the most positive outcome, to 400 days, being the most negative outcome. With time, as project teams perform work that clarifies specifications and define clear UI design, the estimates becomes clearer too. Once the most basic questions about functionality are answered and the initial design sketch for UI is possibly finished, the estimate can be further narrowed down to the slot in the cone which corresponds to the range of 0.8x to 125x. In the example of 100 man days for the baseline, it will mean 80 to 125 days for potential outcomes. While it may be very representative to use an estimated range for presenting an estimate, it is still often much more convenient to use a single number based on the given range and so-called risk appetite. Risk appetite is an amount of risk an organization can take to achieve their objectives in their project goals. It is smart in general to select reasonable expectations rather than to bet on high risk. However, in some situations, for example, when the project team is quite experienced, one may pick a high risk. So how do you determine a single estimate based on the risk range and the risk appetite? In order to do that, we can calculate a standard deviation inside the range and then calculate the expected outcome based on the level of confidence. First, let's take a look at the formulas that we will need for that. In the top of the screen, you could see the formula of simple standard deviation, and then we have formulas to determine an expected outcome based on level of confidence in percentage, baseline, original estimate, and standard deviation, which we calculated in the previous formula. Deviation and the outcome estimate formulas are based on prior broad research on IT projects' performance in the industry. They can be helpful in general case, but can be tweaked based on historical organization and team's performance. This formula is the simplest one. If you want to watch a video for more complex scenarios, such as, for example, with using individual range for each task rather than the sum of worst and best cases, Let me know in the comments to this video. Alright, now let's review a practical example where we will be using these formulas. Alright, so let's assume that our project is in the requirement stage and that the team has provided the following baseline estimates in man days for the project tasks, right? So the project is implement a payment gateway service, and then we get the tasks. Implement credit card payments, 10 man days, implement ACH payments, 15 man days, implement RTP payments, 15 man days, implement recurrent payments, 10 man days, and implement payment settlement, 50 man days. So our goal is to evaluate an outcome based on the provided estimates and apply assuming we have a confidence level of 80%, right? So the risk factor which we account for is 20%. So first of all, let's define the worst case and best case numbers, like estimates for each task. And for that, we can use this corner of uncertainty. And assuming we are right now in the requirement stage of the project, we can take the multiplier 0.67 to 1.5, right? So where 1.5 is kind of like a worst case scenario and 0.67 is the best case scenario, right? So let's calculate and define the best case and worst case numbers for this estimate. So for that, we'll need to multiply them by these numbers accordingly, right? So let's write down this for each task, right? So for this task, best case is 6.7. Worst case is 15. So again, we took these numbers 10, 15, 15, 10, 50, and then we determined the worst case and best cases by multiplying them accordingly to 0.67 here and to 1.5 here, right? So according to corner of uncertainty, we got these multipliers and we multiply these values and we got these numbers basically based on that, right? So now let's calculate the sum of these numbers, right? So we'll calculate, like for example, for these numbers on the right, we have best cases and worst cases. So if we sum them together, we will have a total, which will be for the baseline, it will be 100 man days. For best case, it's 67. Like we can predict, right? And for worst case is 100. So here is the numbers which we will need for the formula of standard deviation. Okay, now let's calculate standard deviation. In order to do that, we need to get the sum of the worst cases, which is 100, and then we need to actually 150, and then subtract it from the best case, sum of best cases, right? It's like 67 in our case. And then we need to divide them by 6 according to this formula of the simple standard deviation. So let's write it down. Standard deviation in our case is 150 minus 67 divided by 6, and that would be 13.83, right? So based on the confidence level, we should select the formula specifically to this level in order to calculate the expected outcome based on the confidence level, right? So basically for 80%, this formula would be baseline plus 0.84 multiplied by standard deviation, right? So that's why let's calculate the expected outcome based on this formula. So basically 100 plus 0.84 multiplied by 1383 Some estimate would be basically 111 days, if we round it, man days. So this is basically an estimate that is derived from our outcome, but it consists, like, it accounts for a risk of 20%, right? Basically, we said that we'll do this with 80% confidence. We are expecting this outcome with 80% confidence. That's what we accounted for in this number. I hope you enjoyed this video. If yes, please share it and press the like button. This makes it easier to share the knowledge. If you're interested in learning more about the methodologies that inspired this video, please check out our channel and consider subscribing. You can learn even more at our website, theplanner.io, where we have various resources and a project planning tool you can use. Thank you, and I hope you have a great day.